Nice brightness. That's awesome. So cool. We got a nice bright light over here. Hey, society, how's it going? Hi, hey, how's it hanging? Awesome. I finally decided to put a load on it. Uh, yeah, I like that. It's this thing right here. It converts the whatever I put from the power supply into my desired voltage. So it's my high voltage device. Awesome. So we're doing 75 volts on one of my circuits, and we got 31 going in on the other, or 32. So it's like placid start, and then you turn down the turbo boosters. You got to turn it up to like 10 just to turn it on, really. Huh. So the reason why there's so many coils is because all my coils are tiny, but when you add them together, they actually turn out to be quite a bit. So that's why I'm doing it that way. um, so I did them on 90 degrees. Boom, 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 boom. Like two 90-degree circuits. Two triggers. And then all that copper in like a series circuit. So you get the good resistance benefits of having all the copper. Now, is it efficient? I would say not entirely the best. No. Yeah, having the rotor be hit from multiple sides definitely turns that up. But sometimes it doesn't catch the little thing that I got. You can hear it trying to. I don't know. I see what you're saying. Yeah. Here we go. Boom. You know when it's on. And there's my Bedini light that's on my circuit. It's a 120 watt halogen bulb. Look at how bright that sucker is. You can tell the voltage is going through it. Hello, Yanni. Yeah, sorry guys. I've been really swamped with life lately. I've been trying to get on, have some fun, talk stuff out, and yeah, but well, I got on now. Been really busy. That's all I'm trying to say. But yeah, I'm glad to be here. Um, yeah, there you go. Thank you, sir. Cheers. So I'm definitely gonna check out Mike's channel tonight. Seems like a lot of people are gonna be there. That's cool, man. I mean, me and him are kind of up the same alley. He encouraged me to do 75 volts on my last live stream, and it works out just perfect, man. It's awesome. He's like, there was a video done a while back where it's like, stop being a wussy, stop doing 12 volts. I watched that video, and I guess it's kind of, he's right. Not about the wussy part, but about it being so much better above 12. And I guess you can kind of say that if you're trying to encourage somebody to increase the voltage a little bit. And it's like, stop doing that. But it's weird because this is how much we're taking from the power supply, and then we put it through that, and it equals 75 volts. All right, I smell something, so I'm gonna turn it down. Yeah, I think when this MOSFET right here, see this big heat sink on there? I think that MOSFET guy is getting hot. This is I would say it's a Bedini-esque style motor. This is the circuit we're using right here. We're getting good output from the coils, enough to light this light up really bright. We're going to take a look at the wave too. Well, we'll see. We're gonna get it. Yeah. So we got this light attached to the positive and negative end of one coil series. I'm just trying to get that fired up right now, though. All right. Yes. Yes. Gotta let it cool off, I guess. The max is 345, but I'm not gonna I'm not gonna go that high. I mean, that's what this thing can do, is 345. Yeah, that sucks. With about that thing, if you don't have, the right kind of wire, exactly, you're gonna draw too much power, and it's gonna get hot. That's the only problem right now. I have quite a few build videos. Um, but I can break this down for you real quick. All right, so the rotor is a 4-magnet rotor, neodymium cubes, south facing out, north facing in. It's resting on a toroid magnet, north facing up. Oh, and the cool thing about this rotor, see those magnets are not falling out of there because this is iron infused PLA, so they're magnetically locked in. And that gives me a lot more confidence going at higher RPMs. And then, boom, it levitates on itself with the 4-inch toroid magnet. And then, all right, that's the rotor setup. Awesome. Then we got this 16 gauge coil with the 26 gauge trigger. And that's connected to this one, and this one. And then this is a tri-filer coil, which is 18, 20, and 32 all in series to finish it off. So that doesn't like go around in a circle like this. It goes boom, 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 like that. And then this is a solo trigger. There's no bifilar here, but the red one and this 16 gauge coil, and then this is my dual drive coil, and it's all hooked in series right now for this project. But that has two 20 gauge strands and two 32 gauge strands, so it can run like two MPNs at the same time. Now what I was going to do is, you see these spokes on this rotor? I was going to print out another one and have, them be on a 30-degree angle. Right? So you guys basically seen, maybe you didn't see, I don't know, but this can get going, spin pretty fast. So if 30 degrees is enough to get, elevation, levitation, see, at 31 volts, that circuit is drawing 100 milliamps. Yeah, I don't like that. There's too much weight on the coil. I'd have to glue it down. I don't want to do that. There you go. But that 31 volts, because there's so much copper, doesn't, that's not very fast. But when you put the 75, man, it's a whole nother ball of wax. Let's see if it's ready to go. Man. Oh, that's frustrating. This might be a short one. We'll see. There we go. Yay! Sweet. So like immediately we're drawing 3 amps, 9 volts, but we're getting 75 out of that. So, and our light is like so bright, and that's our output light. That's brilliant. And there's our resistance light, and that's also brilliant. That's awesome. Now, what I'm going to add to this is I'm going to add 2 piezos or pesos to each one. So that's 4. They're right over here. Just little baby ones. Absolutely. Then it's going to be popping like all over the place, popping. Yeah, I might have to, if I want to play with this more, I might have to glue it down. Because this is just rolling all over the place and it shouldn't be moving. Awesome. Awesome, awesome, awesome. And I know that just took me a while to get started, but I think if I cut it off, it's a lose-lose situation with this thing, because you cut it off and don't let it get hot, and then it might not work at all. And the same thing, if you let it get too hot, then it might not work at all. Yes, this is a DC brushless motor. It's Bedini-esque, I would say. I don't have any extensions on my collector though, not yet anyway. So it's just the solid connection. You got your base, you got 2 connections for your collector, the light and the coil, and then you got your ground for your trigger, you got your um, ground connection, and you got your other light connection on your emitter, and then your base is just connected to the other end of your trigger coil. And that's really all you need to make it work. You can hook it up to a battery, a capacitor, power supply like I have. Yeah, you can do all that stuff. It's very versatile, especially if you don't glue your coils down. And I mean, it's good for them not to move around a whole lot, but if you're able to move them at least in a organized fashion, it's probably going to be that much better for you. I have a lot of options. There are a lot of options. You can do it my way. Or I like to call it my way, but it's not my way. It's the rudimentary way. It's like doing it all like the opposite way that I don't know, I feel other people do it. I like to build it first and then do the science about it later. Or I don't even know if I even do the science half the time. And I don't think it's the best way to do it. I think you should do your homework. And like, you know, I asked a bunch of questions. That's how I learned. That was my homework. I got on YouTube and I asked my audience, how do I do this? If you go back to my starting videos, you'll see that I didn't even know how to build a motor. I was just working with permanent magnets. I didn't even know how to work with electricity until I started doing this. And it's awesome. So you put a longer thread of wire in a series circuit, and then I say you taper from the large gauge or the 16 gauge down to the 32 gauge. I call that the amp funnel because it draws 16 gauge amps from your power supply. But by the time it reaches back to the ground, it's going through a 32 gauge wire, and then you can't force that many amps. Well, you can. You can force it through that little wire, and that's what I think you get half the speed from is doing that. Because it's going from a 16 to a 20, then it's going to an 18, and then to a 20, and then to a 32. So it kind of goes. Wow. See, now this is weird. This is weird. The light is faltering. And turn up the juice just a little bit. There you go. So it was just too low. This is like kind of like because it's a range between like 2 volts, between like 9.5 and 10.5. You go above that, you're gonna blow everything up. There we go. There we go. Look at that. Look at that shaft, man. If you can see that, it's vibrating like crazy. Yeah, I think, especially in my trifilar coils, the impedance is the same. I mean, it's the same length of wire per kind. It's just the different gauges. I'm not sure. I agree, and I think having, especially for a motor like this, having more voltage is way better. But it's weird because if you do the math on the input from the power supply, we're getting more voltage out, more volts out for the 30 watts we're putting in. No, no, it's not the most efficient thing in the world. But I think with the 75 volts, we're getting. Hmm. All right. Welcome, everybody. Just chilling here with the pulse motor. I'm trying to get my second drive hooked up. Maybe if I turn off the light switch while I'm trying to turn this on. Yeah, there we go. It wants to go. So how's everybody been? Yeah, we get better results without that on to start. There we go. Yay. You can hear that thing just screaming. So, like, there's this layer of atmosphere. When you reach it, it sounds like a million people screaming at the same time. Like to call it the screaming layer. Uh, but that's basically where the atmosphere meets the stillness of space. And the Earth is spinning at what phenomenal rate of speed. And when it hits that stillness, you get that basically what you're hearing now, except amplified many, many times over. So cool. Um, these two silver ones, not the red one, but these two have a soft iron powder core, and all the other ones are air core. But it's a big river, flowing into a smaller one, and it's either going to break the bank, which it does most of the time, or it's going to overflow. It's definitely going to saturate immediately. Oh, I can smell that. Yeah, I gotta let this thing chill. That sucks, man. I'm gonna have to find a different way to get up there in voltage. I think this will work for now, but so cool. And I'm still even at 31 volts on the second uh 90-degree circuit here. I'm still drawing 100 milliamps, 130. I mean, and there's a lot of mass there. Yeah, and that's fine. Then 32 is better than all these other ones. It's just I think with the length involved for resistance and everything, this kind of pans out pretty good with the variety. I will just because of the way I chose to do things, will never like agree that having all the coils be the same is the best way. I will never agree to that. I will always say, and I don't know, and I think Mike is right that if you put a 16 gauge wire and a 32 gauge wire together in series, that current flow is going to be of a 32 gauge wire, ultimately. But I still think, and that's just because, so yeah, maybe that is right. And you don't get that surge of amperage from having the 16 gauge coil be first. But for all the other reasons that I mentioned, this is actually working out pretty well. Yeah, current limiting. Uh, that's what we call it. That's exactly what I'm talking about. See, but the current gets limited, but you for all intents and purposes, you get different resistance and you get different mass for the same amount of turns. And I mean, that might be more complicated in the long run, but I mean, if it works better, being more complicated isn't necessarily wrong. And I personally will never know if it works better. I thought 32 gauge alone worked pretty good with like a reed switch. Like it works really good. Yeah, pulse motor generator. There we go. Yay. Oh, look at that brightness. All right, so it's just a standard hookup from the front of the circuit to the rear of the circuit for the light right here. Man, yeah, Mike was right, dude. The high voltage is satisfying. I'll tell them where I'm at. I'm not worried about it. Hell yeah. And I don't have my pezos hooked up yet. When I get those hooked up, that sound is going to amplify by 4 times. It's just going to be popping. Awesome. Awesome. Yeah, I got that smell. You know that smell that I'm talking about when something's getting too hot? Yeah, I got that smell. That's not good. Um, well, really, what happened is me and a homie, Hall Effect X, sat down and had a conversation. I believe Mike Does was around at that point too, and we just hammered out exactly how we were going to hook up our transistors. And this was about a year and a half ago, 2 years ago. As soon as I learned how to do that, it was to the races, man. I mean, I tested everything. You know, I tested 24 different gauges. I tested different ways to hook up coils. I've done a lot of stuff, and I'm pretty sure, honestly, almost all of it's already been done before. But I don't care. I don't want to look it up, man. I just want to do it. And it's not like I don't care what the other people have done. I would just rather talk to them about it than read a book about it. You know what I'm saying? I don't read very well. I mean, I can read if it's a necessity, but it makes my head hurt. So I don't like doing it. But talking, if we can get into a conversation about it, and ask you the right questions, because and I'm trying to learn from you, so I need to ask you the right question because you have the answer that I need. And I got to do it the right way. That's the problem that I have tremendous problem with, man. I'm always like paranoid about stuff, you know? I'm like, and it's just a bad habit. It really is. But I think you know, the pulse motor itself, it's been like a friend to me for a while now. I have, it's gotten me through some difficult times just being able to focus on building it and then having it work properly. It gives a boon, a bolster to, your idea of yourself and what you're capable of doing. So, but I mean, like I said, I had to ask, you know, like the base connection, and you know, I, you connect it to the positive end of your trigger strand. Which is the positive end? The positive end is the end that you started wrapping with. That's your positive end. And then, so what do I do with the other end? Well, you got to ground it to your emitter. So you got your trigger taken care of now. You got one end on the base and one end on the emitter. And the emitter is grounded. So there you've just grounded your trigger coil, which you need to do for it to operate properly. How long does this run for? Like this? Not very long. It gets hot, so I gotta turn it off. See, we're at now 43 watts. 44. Something's getting hot at that. um, yeah, I'm running this on power supplies right now just to get a feel for it. Now this little contraption here will hook up to a 12-volt battery and function properly. I just don't know how long that'll last for. So right now it's running on its second circuit with 31 volts in and pushing through. Let's see how much wire it's actually going through. We got a 16 gauge coil over here at about a third, 3/4 of a pound. We have a 24 gauge coil here. Yay! Yes, thank you. 24 gauge coil here. That's about 3,000 turns. It weighs about 1.5 pounds. And then this one weighs about 2.143 pounds. And it's 20 gauge and 32 gauge. Nice. All right. So we're pumping 31 volts through all of that. And this is a trigger coil for that line. It's an external trigger. I can move it. If I move it over just a little bit, like off center from the red one across from it, it'll start going a lot faster at 31. That's why it's good to have your at least your trigger coil able to move. Just like a reed switch. You know, you move it off center and you're going to get that burst on the edge. Yep, very different magnetic fields. The one circuit is running on less voltage and has different coils. And then this circuit, if I can get it going real quick, is like completely different with more voltage going through. I am from Michigan, United States of America. But I'm a true Michigander, man. I've been lived in like 20 different places in Michigan. Love Michigan. Because it's cold when you want it to be cold. That's why I love Michigan. Two different power supplies. The cap bank is not in uh, commission right now. Yeah, this is. Oh, come on. There we go. Come on. Come on, come on. Yay, here we go. Woo! Now this is 75 volts in on the inverted. There's two 45, two 90-degree anglers right there. Whoo! Dang. Well, the different coil, these are an assortment of coils that I've built over the years, so that's why they're all different. But what I believe the benefit of having a different one is that you don't have to have, um, no, what am I trying to say? You get less, if you need less resistance, you can have less resistance. Okay? Each coil has its own ohms. So the 16 gauge coil is going to have a lot less ohms. And if you need less ohms, that's great. So having a 16 gauge coil is good then. Okay? But they're all in series. So what Mike Does was saying is that if you have a 32 gauge strand in your series circuit, then your whole entire series circuit will have the amperage of a 32 gauge strand. Current limiting. But it's mainly for the resistances and the fact that it's a hodgepodge. Really, it is. But I've kind of done a little bit of the math because I know these are like 2 ohms, a little bit less than 2 ohms. These big 16 gauge coils. These two 20 gauge coils are 8 ohms apiece. So it's like there are subtle differences. There's no real reason though, other than I'll just show you a little bit more of what I have. Like this coil right here is 10 strands of 26 gauge, and it's a parallel wrap. So I can actually hook 10 transistors up to this coil. You know what I'm saying? I got my pancake coil here. Got 2432. Got a couple of those 2432 bifilers that are tiny. Just look at the size of these things, man. They're small, but they're powerful. They let energy just pass right through them. You're not trying to amplify or get more out on the other side. Having the energy pass right through real fast is a good thing. You know? And I had a setup using this rotor right here with 4 of those tiny coils. One of them was actually running another pulse motor. 2 of them were charging 2 batteries, and it was great because I had this wheel powering another wheel over here, which was doing, lighting light bulbs and all that stuff. And then on the same wheel, I had, battery charging going on. It was just amazing. It was immense. It was a mess. But it was awesome. I had like literally 3 motors going on one power supply and in series. It was fun. There we go. Yay. So maybe I can put a resistor on here or something. So I want it to be able to start up more reliable than that. Cheers, Yanni. Thank you. There's actually a diode in between every coil on this. So in every bifilar, quadfilar, trifilar, they're all hooked in series with a diode, and then each coil is hooked to each other with a diode in the respective. So it's only goes one way basically. The only thing that's really heating up fast is this. Um, and that's what's giving me the 75 volts that I'm working with. Yeah, I mean, like I could get a spray and maybe that would work. Yeah, the MOSFET on this contraption gets hot like really fast. And that's because I'm pumping so many amps through it. I don't know if that can really change. I mean, maybe it can, how many amps are being pulled, but I don't think so because I mean, it's already making more volts than it can with the 30 amps that I'm giving it based on the, amperage that's being pulled. So, if you do the math on here, it's 30 watts. And then if you push the 30 watts through this, it's going to come out 75 volts, 1 amp maybe. It's a lot less amps. So it's like a converter of some kind. But I love it, man. This is so cool. And then the halogen bulb is lighting up. That's a 120 watt bulb or volt, 120 volt bulb. Thanks, Josh. And I do believe that I'm maintaining that half-inch coil spacing. I'm pretty sure. Wow, dude. Woo. You're right, but I don't think it's going to happen tonight. Well, I mean, do the math. Do the math yourself. 75 volts are coming out the side of this thing. Uh, so I don't know, man. I did the, what do you call it? The tach meter or the multimeter reading on the end of it. Let's do that again with it hooked up and see what happens. Yeah, I smell burning transistor. That's what I smell. But it's just because it was hot. Let's see here. Where's my other clamperoni? Over here. There it is. All right, so we got our DC on. Dang. Okay. All right, let's try that again. So 72. Just gotta get it kicking here. But see, it's turned on. It's not pumping though. There we go. There we go. All right. Kind of sucks having to do that by hand. Okay, so this is the amount that's coming out the end. So it's a little bit less than I thought. 61. This is with it being on. So 61 volts. So cool though, man. And we can turn it up. You know, this is its lowest setting. But I think honestly, with that much voltage, I can afford to put another 32 gauge coil in here. Like a big one. Yeah, it is. Absolutely, man. This thing is freaking amazing. Like with the high voltage, awesome. Yeah, I made the thicker coils to have less of a turn amount. Actually, that's why they are the way they are. But yes, definitely need more to get those amps down. I mean, Jesus. I think it's the same way to do it. See, and I guess when turning it down, you can make the voltage go lower. But at 9.5 is where it turns off. Wow, so much fun. No, that's what I'm putting in. That's 60 odd volts in. And I don't have anything for the, let me see here. This one might work for the out. Let's look. Yeah, I think this one is hooked up to the output. Let's see what happens. Okay, and this is with the 100-watt bulb for a load. So where I have the line hooked up right now is not a good spot for a reading. And it's hooked up. It's got the whole series coil set up in there. I mean the voltage reading's good, but the sine wave reading is not good. It's been better. It's been better. Maybe I'll do an individual coil real quick instead of the whole system. We'll do one of these 20 gauge coils. All right, now let's see what we get. There we go. There it is. All right. And that's just one coil in the series. We're getting 84 off of that. Nice. It is a negative dominant right now. Negative dominant. So you know what else I can do is I can hook the signal generator up to the high voltage circuit and pump, kilohertz into the coil system. Yeah, they are not very smooth. And that's just on the one coil though, and it does have a powder core. Yeah. You see how it started out though? With the four, each one of these lines here is four spikes. Let's do this. I haven't done this yet. Wow, dude. Wow. Sorry. Let's see here. Jesus. Divide that by 4. Dang. That's like 1,000, 1,500. So is that why it's shaking like that? I mean, there could be numerous reasons why it shakes. Thanks, Josh. Yeah, that's what I was thinking. Right around 1500 RPMs, it starts shaking, like the pole just starts vibrating. And I'm like, oh man, it can go way higher than that though. Mm. Well, I really appreciate everybody hanging out. I'm probably going to go make dinner now for my family. I appreciate it. So thank you very much. Peace out. Have a wonderful night. Bye now. Later, Mike. Later, Yanni. Thank you. Ah, true that. Well, I think it's pretty good. Uh, bye now.